All right, guys, we're going to go over some square root work. Okay, we're going to look at 5 different problems that you saw on your homework. Okay, first one, we have a square, and it's telling us that the area of the square is equal to 49. And I want to know how long the length of the sides are. So how long is it from this corner to this corner, which we don't know, so we'll call it S. Well, to find the area of a square, we do length times width, just like we do a rectangle, but the length and the width of a square are exactly the same. So the formula for a square looks a little different. It's area equals side to the second power, which means that this number got squared to turn into 49. So we're asking ourselves, what matching number multiplied with itself to make 49? And through some process of elimination, we can probably figure out that 7 times 7 equals 49. Another way of writing that is 7 squared, right? So we use common sense there to figure out what 2 matching numbers multiplied to make 49. But what we're really doing there is we are going to the root of this squared number, which is known as the square root. So another way of finding this length of the side is to take the area and to square root that number. So this sign is called the radical sign, and it means that we're doing a root, and we're doing the square root because we don't see any number over here to make it distinguishable from being the third root, fourth root, fifth root. So it's automatically the second root, or what's known as the square root. So what we said is that 49 is the same thing as saying 7 squared. And what we also talked about in class is that the radical sign, the square root, is the inverse operation of raising something to the second power. So when I do the square root of 7 squared, I'm actually canceling out that power of 2, and it leaves me with just 7. And that is how long the side of a square is that has an area of 49. So taking away the shape of a square and just moving straight to just doing a square root problem, I have to ask myself, what matching number multiplies to make 64? And hopefully, we remember that it's 8 times 8 makes 64. Which means that the square root of 64 is really the square root of 8 squared. Again, square root, raising something to the second power, known as squaring, are inverse operations. So they cancel each other out, and we're left with just 8. So this one is pretty similar to it, except we see that there's a negative sign outside here. So the matching number that multiplies to make 25 is 5 times 5, which means that I'm doing the negative square root of 5 squared, which is equal to negative 5. So it's the same exact type of problem as the last one. It's just that there was a negative on the outside, which means that the answer is negative as well. Okay, on to something a little tougher. Square root of 2034. Well, when it comes to large numbers like this, what I like to do is I like to take every possible answer that there is in the universe and bring it down to a range of only 9 possible answers. And the way that I do that is I think about multiples of 10 being squared. 10 squared is equal to 100. 2034 is way too big. 20 squared, 20 squared, that is terrible. 20 squared is equal to 400. 30 squared is 900. If you haven't figured out, all I'm doing, I'm squaring the front number and adding 2 zeros. 40 squared is equal to 1600, and 50 squared is equal to 2,500 or 2,500. And what we should notice is that the number that we're trying to square root, 2,034, falls in between these two numbers, which means that the square root of 2,034 is between 40 and 50. Okay, so we know that it's definitely not equal to 40 because 40 is 1,600, not 2,034. And 50 squared is 2,500, not 2,034. So that means that there's only 9 possible numbers to choose from. 41, 42, 43, 44, 45, 46, 47, 48, and 49. So we've just limited the answer choices down to 9 numbers from all the numbers in the universe. So now we're going to take these 9 numbers and we're going to limit it down to 2 numbers that are possible. Because I know that after I multiply 41 times 41, 42 times 42, 43 times 43, and so forth, the number that I get has to end with a 4 because 2,034 ends with a 4. So if I try doing 41 times 41, 1 times 1 is going to be a 1. And that's what the number is going to end with after I multiply the whole thing. So I don't have to multiply all of 41 times 41 because I know it's going to end with that 1. That's not a 4. So this gets eliminated. 42 times 42, however, will end with a 4. So we're going to keep that one. 43 times 43 is going to end with a 9, not a 4. Eliminate. 44 times 44. Well, 4 times 4 is 16. Carry the 1, and it ends with a 6. Eliminate. I know that's going to end with a 5. We all do. Eliminate. Times 46. That's going to be 6. Carry the 3. Ended with a 6, not a 4. Eliminate. Times 47. 7 times 7 is 49. That ends with a 9, not a 4. Multiply by 48. 8 times 8 is 64. Carry the 6. That ends with a 4. We're going to keep this one. And times 49. 9 times 9 is 81. So that eliminates. So we have 2 possible answers. We have 42 and 44. Now, the more that you start to do this, the more you start to not have to write all of these out because you know that there's only 2 possibilities that end with 4. Things that end with 2 and things that end with 8. So you don't have to go through all these checks after a while. This will always end with 1, so will anything that has a 9. This will end with 4, anything with 8 with a 4. Anything that ends with a 3 will make a 9. Anything that ends with a 7 makes a 9. Anything that ends with a 4 makes a 6. Anything that ends with a 6 makes a 6. And 5 always ends with a 5. So now we just take these 2 answers, we bring them down here, and here's where we actually have to multiply all the way out to see which one is the right answer. 2 times 2 is 4. 2 times 4 is 8. 0 for the placeholder. 4 times 2 is 8. 4 times 4 is 16. Add 4, 16, carry the 1. 1764. 2,034. Not the right answer. So if this is a perfect square, which I'm pretty sure it is, because I made up the problem, 8 times 8 is 4, carry the 6. 8 times 4 is 32, plus 6 is 38. Placeholder. 4 times 8 is 32, carry the 3. 16 plus 3 is 19. And if I add this, 4, 10, carry the 1, 13, carry the 1, 2,034. So that means that the square root of 2,304 is equal to 48. I know it looks like a lot of work, but the more that you do it, the more you get used to the method. Finally, the last type of problem. 3x squared equals 75. Well, this is an equation. And anytime that I see an equation, I automatically think of SADMEP. SADMEP is PEMDAS backwards. And it tells me the order that I should cancel things out using inverse operations. So the first things that I always look for in an equation are subtraction and addition. I want to cancel those out first. So I look up here, x squared, that's being squared, and that's 3 times x squared, so there is no subtraction and adding. Don't need to do it. Now I look for dividing and multiplying. And as I just said, that is 3 times x squared. So 3x squared equals 75. First thing I'm going to do is cancel out the multiplying by using its inverse operation of division. So that leaves me with x squared equals 25. So with some common sense, you could probably figure this out. But we're going to look back at SADMEP, and we have exponents right here. Now, earlier in the video, I said that the inverse operation of an exponent is the root. So we need to do the root of something being squared. So that would be the square root. So we square root both sides. So the square root of x squared cancels out the squared and makes x. And the square root of 25, we say, is plus minus 5. And the reason why we say plus minus 5, because positive 5 times positive 5 makes positive 25. And negative 5 times negative 5 makes positive 25. So that would be our solution right there for 3x squared equals 75.